this is the limit as x approaches infinity. So it's still e. We saw that e. So basically, you have natural log of 1 plus 1 over x, and then this x over here, we write it down here as 1 over x, right? So this whole thing, basically, it's e raised to this entire thing, right? This is the entire exponent of this e. So basically, we write it this way, so that way we have a fraction. So now we have a fraction, so we can use L'Hopital's rule, right? So L'Hopital's rule basically says, you take the derivative of this, take the derivative of that, as long as it's indeterminate, right? So if this was infinity, you would have natural log of 1, that would be 0. If this goes to infinity, this is 1 over infinity, which is also 0. So you would end up with 0 over 0, which is indeterminate. So this is how you can use L'Hopital's rule. So now, once we take the derivative of both these things, we'll get our answer, basically. So now we have the limit as x approaches infinity of, okay, so the derivative of this, so is basically 1 over whatever's in the log. So it's going to be 1, so it's just 1 over 1 plus 1 over x. And then you multiply by the derivative of whatever's inside here, right? So derivative of 1 is just 0, derivative of 1 over x. You do the power rule, so that's just negative 1 over x squared. Okay, so this is negative 1 over x squared. And by the way, all this is raised to the e, by the way, don't forget the e. So now we take the derivative of this, which is just negative 1 over x squared. Okay, so we're taking the limit of this whole thing. It's a little messy, but basically that's what's happening. So what you notice is that, first of all, these cancel out, right? The negative 1 over x squares, they cancel out conveniently. So now what we have, let's move over here. So now what we have is basically the limit as x approaches infinity of what we have left, which is e raised to the 1 over 1 plus 1 over x. Okay, so basically this is what we have left now, right? So now let's see if we can plug in infinity. Okay, so if we do that right now, we have 1 over x, 1 over infinity, and so that's going to be 0, right? 1 plus 0 is just 1. 1 over 1 is 1. So basically, you end up with something that's not 0. Or, well, I mean, it could be 0, but basically, like, it's something determinate, right? It's not like, something divided over 0 or something like that. So if we plug in if you plug in infinity into this, what we end up with is e raised to the 1 over 1 plus 1 over infinity. So this is just 0.
Yo, can y'all sit down and take me? I know, I'm sorry.
And that's e to the first power or just e. Okay. So basically, this limit all the way over here, the limit as x approaches infinity of this thing, basically this equals e. Okay. So it's a famous limit, and that's basically how you do it. Other people do it in different ways. So this is just the way that I do it. So that's it. You can